So we're going to continue solving quadratic equations. This moves into chapter 15, I think section 3. So one of the things I suggest to solve quadratic equations that are not factorable is one of the strategies is what's called completing the square. So in completing the square, it takes several little steps. So how do we go about completing the square? So remember, completing a square means we want a perfect square. So to be a perfect square, we have to have like a plus b squared equals like a squared minus 2ab plus b squared. Or if I have this a minus b squared, then this is this should be plus up here, a squared minus 2ab plus b squared. So those are two forms. So in completing the square, you're going to be given a trinomial, x squared plus, say, 10x. And what we want to do is complete the square. To complete the square basically means we want to know what this number here is that makes a perfect square. To do that, all we got to do is take half of the linear term. Half of the 10 would be 5 and square. Well, half of 10 is 5 and square would be then this 5 squared or 25. A lot of times I'll leave it as like 5 squared. So what this tells me then, this is your A, this is your B, and since the middle term is plus, this tells me that this is going to factor then to x plus 5 squared. So we have to kind of isolate the quadratic term and the linear term on one side of the equation. So in solving our problem, this 9p squared minus 12p minus 2 is equal to 0. The first thing we have to do is isolate the quadratic term and linear term. That means the minus 2's got to go to the other side of the equation. So my first step is I'm going to have this 9p squared minus this 12p, and I'm going to leave a little space here, and that's going to equal then this 2 over here, since we're going to add 2 to both sides. The next thing is the coefficient of the p squared has to be a 1. So what we can do is divide everything by a 9. So if we divide everything by 9, this turns into p squared. We also got to divide 12 by 9. So 12, let me see if I can get this where I can see it. 12 divided by 9. That gives us a fraction. So let's change it back to a fraction there. That's going to be 4/3. So that's going to be minus then this 4/3 p. And then 2 divided by 9 is going to be this 2/9. Now, to complete the square, what we do is take half of this 4/3. Well, to take half of 4/3 means to multiply it by 1/2 or divide by 2. So if we divide that by a 2, that gives us then this 2/3. So, and then we're going to square it. So what this tells us to do is add a 2/3 squared here. But to balance the equation, we have to add a 2/3 squared on the other side of the equation. But we can go ahead and do the math on the other side. 2/3 times 2/3 is going to be back to this 4/9. So the next thing we do is this now is going to be factorable. It's going to be this a minus b piece. So we have a p minus then this 2/3 squared. And then we just got to add 2/9 plus 4/9 is going to give us then this 6/9. Now, if I rewrite this, p minus 2/3 squared equals, notice that the 6/9 I can actually divide a 3 out of the top and bottom, and that's going to turn into 2/3. Now, once we've got it in this form, we can now take the square root of both sides. So we take the square root of both sides. In doing so, the power 2 and the square root will cancel each other out. And this will give us then this p minus this 2/3. And over here, we're going to have then plus or minus the square root of 2/3. So it's going to be the square root of 2 over the square root of 3. Now, we typically don't like to have the square root of 3 on the bottom, so we have to do what we call rationalize. To rationalize means we have to multiply the top and bottom by a radical 3. By multiplying the top and bottom by a radical 3, then this allows us to do a little bit more math here. So I'm going to have to move some step down a little bit. So what happens then is we have this p minus 2/3. And this radical 2 times radical 3 is going to turn into a radical 6. So this is going to be plus or minus this radical 6. On the bottom, radical 3 times radical 3 is going to be the same thing as 3, because radical 3 times radical 3 is going to be the square root of 9, which is back to 3. So that gets rid of the radical off the bottom. So then all we got to do is add this 2/3 to both sides. So we end up within p equals 2/3 plus or minus the square root of 6 over 3. And if we want to, we can, since they have a common denominator, we could write this then as 2 plus or minus the square root of 6 over 3. So there's actually two answers here. If you want to separate them, you can use a plus or minus, but you can also separate them using a comma. So you also could say p equals 2 plus the square root of 6 over 3, comma, 2 minus the square root of 6 over 3. So notice that completing the square can require a little bit of math. Notice how we can also do this problem using what's called the quadratic formula. So I'm going to redo this problem this time using the quadratic formula. So notice how we have, let me make some room again. So if we use the quadratic formula, we had 9p squared minus 12p minus 2 was equal to 0. Let me double check myself there. 9p squared minus 12p equals 0. So using the quadratic formula, I can say x, or in this case, p equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. Notice that in the formula, the coefficient of x squared is the a, the coefficient of the x is the b, the constant is the c. So in our problem, the a is actually the 9, the b is the coefficient of the p, which is the negative 12, and the c is the constant, which is the negative 2. So if we use the quadratic formula, I can say p equals, and the first thing it says to do is take the opposite of b. So the opposite of a negative 12 is a positive 12, plus or minus then the square root of, and then we have to go b squared minus 4ac. So negative 12 squared, if I put that in my calculator, I have to put that in parentheses. So if I clear that off, so I have to put the negative 12 in parentheses to do that correctly. Squared, because we know that a negative times negative is a positive, so it's going to be a 144. Minus then 4 times a, which is 9, times c, which is negative 2. So I still got a little bit of math to do inside there. And then on the bottom, we have 2 times a, so it's going to be 2 times 9, which is 18. So p is going to equal then, and one of the first things I want to do is go ahead and simplify this radical. So I'm going to work what's inside there. 144 minus 4 times 9 times negative 2. That's going to give me then this 216. So I have 12 plus or minus the square root of 216 over 18. Now, to simplify this, we actually have to simplify the radical first. So to simplify the radical, we can use a prime factorization. So I'm going to put the 216 up here, and I'm going to use what's called a prime factorization. Remember, our prime numbers are this 2, 3, 5, 7, 11, 13. Those are our prime numbers. They're very powerful in helping us work things when they want exact answers. Because I actually, if I look at the directions, they want exact answers. So that means I have to leave it in what's called a radical form. If I just take the square root of 216 on the calculator, it'll give me a decimal, and they don't want the decimal, so we're not allowed to do that at this point. So what I can do is start using prime numbers to break it down. So we know that 2 does go into 216. So if I divide 216 by 2, that sounds like that should be like a 108. So it's going to be a 108. It looks like 108 is also divisible by 2. So if I divide that by 2, so 2 goes into 108 54 times. It looks like 2 also goes to 54, so 2 into 54. If I divide 54 by 2, that's going to give me 27. Now it looks like we're moving to threes. So 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into 3 1 time. Now to do radicals, for every 2, we bring out 1. So notice how there's a pair of 2's and there's a pair of 3's. So that means we can bring out a 2 and a 3 outside the radical. So as we do this problem, we kind of pick up on that P is going to equal then. So P is going to equal this 12 plus or minus. To simplify this radical, we pick up on that 2 times 3 would be a 6 is going to come on the outside. And what we're left on the inside is a 2 times 3, which is a 6. And this is going to be all over 18. Now to finish it out, we can separate this as 2 separate fractions. So 12 over 18 plus or minus 6 squared root of 6 over 18. And then we can reduce each fraction. Notice that a 12 and an 18 both have a common factor 6 in them. 6 goes in 18 twice. I'm sorry, 6 goes into 12 twice, and 6 goes 18 3 times. Then we have our plus or minus. Notice that here, these outside factors have a common factor in them. 6 goes into both of those. So 6 will cancel out, and 6 goes 18 3 times. So we're going to end up with the square root of 6 over 3. So since we have a common denominator, we can't put those together or just leave it as is. So we can leave the answer as 2/3 plus the square root of 6 over 3, comma, 2 minus 2/3 minus the square root of 6 over 3. So I can also use the quadratic formula there to do that. And do we get the same answer? Yeah, it looks like the same thing. 2/3 and a square root of 6 over 3. So we have 2 ways to kind of go about doing that problem. Completing the square or the quadratic formula. I know the directions say complete the square, but feel free to also just use the quadratic formula.